So I've got my hash table. We said we needed nodes, so because we needed nodes, I'm just going to go steal chained lists node because it's sort of what I want. Oops. Okay, so there's a node class. Hash table. If we were to make a hash table, let's go into the driver and let's say hash table, a table equals new hash table to make the table. What's the interesting thing about hash table? You're trying to pair up, in this case, string versus student, and in this case, student versus student.
You need to specify what your key and your object.
So it takes, yeah, it takes two pieces of information. It takes a key, a unique thing, and it takes a value that's associated with that key. Right? There's your associative word. Okay. So since it's a, you guys know it as a key value pair, we would do something like we would say hash table is string and student. Two things now, a new hash table. Hopefully it'll let me do that with those two things. Okay, actually, I'm going to use, I got worker here. Same thing. That's the Afrikaans version. I'll get it right sooner or later. Yeah. Oop. It's going to be one of those days. Okay, so hash table takes two things, a key and a value. So here in hash table, we're going to have to change it to take a key and a value. And the tradition, again, is to use just uppercase single letters for those. So the thing that we're actually storing in a node is a what stores it in the picture? Well, the thing that's a pair. So we're actually going to have private class a pair of items that we're trying to group together. The pair of things constitutes a key and a value together. I actually probably don't need to say that there, actually. Let's just do it this way. And so what we're going to have is and the value paired together. So those are the two data items that we started out with. We're going to find a way to group those together. The way you group them together in Java is to form a class around them. So there's the pair of things that we're going to group together. So the thing that's stored in the node class is something that refers to a pair of things. Okay, my toString I'm going to take out of there because it's probably wrong. Okay, so just looking at the diagram, the node contains a pair and a link to the next node on the chain. Yeah, I just threw that piece of garbage in there.
Interesting that it auto puts in the import statements, but it won't auto implement methods for you.
Yeah, it's a little silly in this version. There's a new version of Eclipse coming out, by the way, at the end of the month. So you can get the release candidate is up there already, and it works with Java 8, except you have to download Java 8 from Sun or Oracle, sorry. Okay, so what do we start out with in our table? an array of nodes, so node array, we'll just call it our table, and our constructor needs to initialize the table. What we'd like to say is new node array size, pick some arbitrary number, and it's sort of not going to let us do that. Well, that's the C version. If we do the, it still doesn't like it. Yeah, this is the little weirdity. So we say, okay, what we'll do is we'll make a new array of objects, and then we'll cast it to a node array afterwards. Get out of the way there. Okay, for now that'll work. Okay, so there's our 100 elements in the array. That can be any size, really doesn't matter. We'll just stick with 100 for now. Okay, back to the driver. So we've made our hash table, and then somebody comes along and says students.add no, students.add. Let's do the let's do worker with worker, just because we can see what happens there a little easier than with string. So I'm going to add a worker to the tree. Let's make a worker here. With whatever he does. Okay, and so when we add him to the table, we add Fred to the table with the two arguments now. One's the key and one's the value, so Fred generates his own key. So let's write the add method. And so what we get is a key and a value. There we go. So we want to put somebody into this table. How do we put them into the table? Make a new node or a new pair of things to start with to group those two values, those two things together. So we'll make a new pair with the key and the value, which needs my constructor. This way. So we made our pair. Then what?
So we have the pair to a node.
Yeah, I made grouped those two things. There's the key and the value grouped together into a pair. So now I'm going to need to make a node to remember the pair so that I can eventually chain it onto the list. So we'll take the pair and we'll drop it into a node. Got it. So now we've got the node that we'd like to put in the table. Where do you want to put it in the table? Who's going to give us the number? the key is going to give us the magic number, key being the unique magic number, right? So we'll turn around and we'll say int magic equals a key dot get magic number, whatever that number happens to be. Oh, okay, so that's sort of interesting. That means in order for this thing to work, the worker class has to have a public int get magic number what should we return?
Do first name, convert to a number.
We could convert the string to a number. We'll figure out how to do that later. Why don't we just make this an integer social security number for now? Because we know how to work with those. And we'll do and I'll wipe that out. And I'll wipe out title because that's really all that we need. And I'll change my driver to throw in some number, 61. I'm just going to shorten it up a bit, 852. Save this before it runs away. It should be key rather than a key, right? Oh, we'll get to that. We're just going to do it a little bit by hand here. Let's see. Yeah, we're going to get a little bit stuck here. Just trying to think of a way. The reason we're having a problem is that this thing has to have one of those get magic number functions, and we don't really know what it is. So I'm just going to cheat and do the right thing at this point. In real Java, the thing isn't called give me a magic number. It's called key dot, actually, hash code. Okay, and just to point out how useful that thing is, if you go to the documentation and we go to class object, if I can find it. Here's class object, and we have a look in class object. It doesn't have a lot of methods that you start out with. Notice it has a toString by default, and notice that one of the things that's in object is hash code, returns a hash code value. So any object will be able to give you its own unique identifier. What do you think an object by default returns for its unique identifier?
Memory location.
It's memory location, because that's the thing that's unique. Okay? And so what we're going to do is when we make hash code, we're going to override hash code to change the behavior from saying it's the default memory location to it's something else. Okay? So since every object has one, that's why I can get away with calling key.hashcode here rather than having to worry about making a silly interface or something to keep track of it. It's already there. So what do you think? So now if we go back to worker, if it wants to change hash code be more specific for itself, what would it change it to? The unique thing that identifies it. Okay, so we're going to say for our purposes, the unique identifier for any worker is by their social insurance number, not by their memory address. Okay? Got it. That makes hash table happy. So we get the hash code. That's going to be a really, really, really big number, hopefully, but we only have table size 10. So we need to scale whatever number they gave us down to fit within the size of the table. Have you got something that does that in your vast array of Java-isms? Remember the other day we did 10 divided by 6 is what in primary school? 1 with 4 remainder. Okay, so the divide operator gives you that thing. If you do 10% 6 in Java, you get that thing, which is the remainder, the leftover portion, right? Good thing about remainders, always less than that thing by definition. Otherwise, we would have clicked 1 over. Okay?
So you take the number and then modify
So
the size of the array.
what we'll do is we'll get int table slot is the magic number % sign
Array size.
table dot length. Okay, so that just scales the thing to fit in the size of the table, always guaranteed to be less than the size of the table, happens to use the last rightmost, did I get that right? The rightmost digits of the number. You could do anything in here, I mean, just as long as it fits in the size of the table. The mod operator just happens to be the easiest way to scale it into the table. Okay, and then just imagine that it's the only thing in the table. How would you place it in the table?
You take the node and put it into that slot.
Table at
Table slot.
table slot position.
Is table.
So that's assuming that they don't collide with each other, which is probably a pretty good bet at this point, and that would insert it into the table. How much time we got? Oh, we can do find. Oops. Suppose that in the driver you wanted to search for Fred. What information would you supply to search for Fred? Think of any search that we've ever done up to this point,
Looks like.
using index of, for instance. The thing that you're searching for is something that looks like the one that you're trying to find. What's the thing that identifies the one that you're trying to find?
Their name.
The thing that's unique about them, that uniquely identifies them, is their social insurance number, and you don't care about any other piece of information. So what we'll do is we'll search for a new worker, don't care, with the same social insurance number. There's the unique thing. Okay, and we'll do a quick job of writing find. The thing that's going to come back is what?
Worker.
If you
So value.
the value, and the thing that you're going to supply to find is the key. So you supply the unique thing to find them, and what you get back is the one that you were looking for. How do you find them in the table?
Traverse the table, do these equals.
How did you put them into the table?
Yeah, you use magic number.
You need to get their magic number and then search for them in the table. So we would do this to find their table slot, and then what?
Well,
Let's just assume that they're actually there.
yeah, then you compare what you're looking for to what's there.
Well, just assume that there's no collisions, because we didn't insert them with any collisions, and we'll go back and do the collision part later.
Then what is there is what you want.
What is there is what you want, right? It's either null because there wasn't anything, or it actually is the thing you're looking for. Assume that it's not null, assume that it's the thing that you're looking for, the happy thing. We would get table sub
The full slot. Dot item.
well, do it in small pieces. This is what we're actually looking for, but what comes back at this point? So node, a node is that. And then, is that the thing that you were trying to find?
No.
So the thing that comes back from that is pair, it's just the reverse, is a node dot stored item is the value, and then value is a pair dot value. So it's the reverse process, and then we'll send back value of the way we put it in. Okay? So we made a pair, we made a node, insert it into the table. The reverse of that is find the table slot, drag it out of the node, get the thing out of the pair. Okay? And assuming that the item is there, that's all the work that does it. Notice how little code that is? It's like, so far it's trivial, and that thing is one of the fastest searches that's possible. And generally, the only other thing I'll say is that the goal of the hash code function is to calculate something that's unique about them, but use very little CPU time to do it. So you don't want a hash code function that hashes all of their information. You want the minimum amount that makes them unique. So that's why social insurance number is no calculation at all. There's the social insurance number. Okay, string goes to a little bit more trouble, but we'll talk about the string tomorrow. See you tomorrow.